Hi class, so today our topic is compound inequalities, and this is something that is typically at least started to be covered in middle school, so hopefully you'll look at this and think that this looks familiar in some ways. And there are two types of compound inequalities that we can talk about. We can talk about compound inequalities with the word and, or compound inequalities with the word or. Now, compound is a word that means multiple things being together. Okay, so when things are combined or put together, they can be attached with either the word or the word and. And the first one that we're going to look at is the word or. So let's say we have two inequalities. So maybe we have something like x is greater than 5. And we have another inequality with x is less than or equal to 0, right? There are multiple inequalities, and we are going to attach these with the word or. This is a compound or inequality. And just like with all inequalities, we can represent what this looks like on a number line, right? This is saying that x has to meet two qualifications, okay? It can be greater than 5, or it can be less than or equal to 1. So that's kind of abstract to think about when it's just verbally or visually written down. But if we see what this looks like on a number line, it's going to help us see what this means. And when we want to graph a compound inequality, just like I said before, you're really going to want to avoid putting 0 in the middle of the number line because your number line is going to get huge if these numbers are negative 47 and 562. The key is just that we're going to want our smaller number, whichever of the two is smaller, on the left, and our larger number on the right. You do not need to fill in all the numbers in between because, again, if it's negative 47 and 152, that's going to be a really huge number line. Now, to start with, we just kind of want to graph above the number line to see what's going on. Okay, so if I have x is less than or equal to 0, we'll graph this with our normal rules, right? Less than or equal to says to use a filled-in circle, and we are then going to shade to the left. Okay, then we're going to look at our other inequality and graph it based on our normal rules. X being greater than 5 says to use an open circle and to shade to the right. Now, when we are talking about the word or in the English language, right, if you're allowed to pick out a shirt or a pair of pants at the store, right, you're just getting one of them. You're not getting both of them at the same time, you're just getting one. So for our final answer, we want to bring down onto the final number line anywhere where one of them is happening. Okay, so x being greater than 5 is happening over here, and x being less than or equal to 0 is happening over here. And my students are like, Mrs. McKinney, why did you graph it above if that is the exact same thing? It is a little bit weird right now, but it's going to make sense as we keep going, so just bear with me for a little bit and trust me. Now, just like, so this is our final answer of the graph, right? That means we can pick any numbers that are over here and smaller than 0, or any numbers over here that are greater than 5. Okay, but just like with solving inequalities, okay, we can solve compound inequalities. Compound or inequalities are super simple to solve. Okay, so let's say we have this compound inequality, right? Again, it's just two separate inequalities attached with the word or. The only catch here is that they're not solved. So when we're talking about solving a compound or inequality, we're just going to solve them like we would solve a regular inequality. Okay, so I'm just going to solve this one over here and pretend this doesn't exist. Right, so I'm going to undo addition with subtraction. And then undo multiplication with division. Okay, so that's one half of it. And then I'm just going to solve the other inequality all by itself as well. So I'm going to divide by -2, The rules are still the same here, so they don't change. So we divided by a negative. So that is a reason to flip the inequality sign. And then just like before, I could graph this answer where whichever one is smaller is going on the left. It doesn't have to be the right one. Either one could be smaller. Okay, and I'm going to sort of consider what's happening with them normally, right? So normally this would be a filled in circle to the right, and this would be an open circle to the left. And any place where either one is happening is part of my final answer, right? So the x being less than -8 is happening over here, and the x being greater than or equal to 6 is happening over here. Now, we can also talk about compound inequalities that are attached with the word and. And is where things get a little bit more tricky. So maybe we have x is greater than or equal to -4 and x is less than 7. The key to understand is that and means we are getting both, right? You're getting a shirt and a pair of pants. You're getting both of them at the same time. Okay, so if we are getting both of them, we want to make sure we are considering what that looks like on the number line for both of them. So we're going to start this out the same, where my -4 is smaller going on the left, my 7 is going on the right. Okay, so this is a filled in circle shaded to the right. And this is an open circle shaded to the left, right? I'm just kind of looking at what's happening. Now, I want to know where I'm getting both of them. Where do they overlap? Okay, and that overlapping piece is what we want to be on our final number line, right? So right here in the middle, we have that pink and green at the same time. Our circles stay the same. So this is still going to be a filled in circle. This is still going to be an open circle. And we are shading that area in between. Okay, and then we kind of go, okay, I see why we're sort of considering this stuff above. But that doesn't necessarily seem that much trickier. The problem is that these can be combined and written as one inequality with no word being seen. So it could look like 6 is less than or equal to y, which is less than or equal to 12. Okay, so if we see the word or, it's a compound or. If we see the word and, it's a compound and. If we don't see any word at all, it's a compound and. Okay, so this is still a compound and inequality. It's just kind of all stuck together in one big problem. And we can start this off by graphing it exactly the same. So our 6 is smaller, so it's going on the left. Our 12 is larger, so it's going on the right. We have to be really careful with this one. This half is pretty straightforward. Y is less than or equal to 12. So I'm doing a filled in circle at 12, and I'm shading to the left. The other half is a bit more sneaky, right? This half right here. This half says 6 is less than or equal to y. And remember, our graphing rules say that we cannot graph unless that variable is first. So if I rewrite that with the variable first, that is a reason to flip the inequality sign. Okay, so once I flip that sign, then I'm good, and this is a filled in circle to the right. And again, because this is compound and, I want where they're overlapping. I want where both of them are happening. And so I'm going to go in this middle portion. Okay, now just like compound or, we could also solve compound and. And it's the same idea as compound or. If we see the word and, we'll just solve them both separately. Okay, the problem comes into play when it's all put together. Okay, so now we have a compound and inequality that also is not solved. So we need to solve this compound inequality. Now, some of you may have seen from teachers in the past that you can split this apart into two inequalities, and you can do that. There's nothing wrong with it. It's just more work. We can easily solve these when they're squished together. Okay, and the way that we're going to do that is just sort of cover up until we get past that first inequality sign and treat this just like a regular inequality. Okay, and if we were to solve this, the first thing that we would do is add 4 to each side. And just like with any equation or inequality, right, whatever we do to one side, we have to do to the other. The catch is that this has a third side. So whatever we do to one side, we have to do to both of the others. So those still cancel out. And we're still just bringing down. And then we're going to repeat that process. So we'll cover up here. Okay, normally if I saw this, I would divide by 2. But again, whatever I do to one side, I'm going to do to both of the others. And so when I solve this, I will get 6 is less than or equal to W, which is less than 10. Now, obviously, we could graph this using the exact same graphing rules that we were just talking about. But for now, we're just going to keep that in its solved form and not graph. Okay, I want to look at one more just to sort of make sure we're okay. Doesn't really matter what's in the middle of this. It's the same concept. But my students tend to sort of see those fractions and go, I don't know, Mrs. McKinney. Okay, so 24 is less than C plus 4, all divided by 3, which is less than 30. So I'm going to cover up until I've got that first inequality symbol covered. Don't go any further, just that first inequality symbol. Okay, and here to solve this, we would undo dividing by 3 by multiplying by 3. And again, that's going to happen in all 3 places. So 3 times 30 is a 90. Those cancel. We have a C plus 4. Let's see, 24 times 3, 12, 72. We'll cover again. We can undo addition with subtraction. Whatever we do on one side, we have to do to both of the other sides. And once we have C by itself, we have it solved.